To illustrate the dependency injection in Kotlin, I'm going to create a couple classes here so we can take a look. Okay. So we're going to use the same example of car and engine that we talked about in the previous video. So you will also notice that I'm using Kotlin Playground here. It's an online Kotlin text editor that allows you to write some code and compile and run in real time. So in this case here, I can click here. You can see hello is printing there. Instead of using an IDE such as Android Studio or any IDEs or text editors there, this is simple and quick to get to. You are free to use any other text editors there. What are we going to do here? So I'm going to get rid of this first, and right below here I'm going to create a class called car. Okay, it's very simple. In this class we're going to have a function. In this function I'm going to call start car, and this one would say print ln. There we go. So that's the first class. And then we understand that a car needs an engine. Engine as such. In our class here, I'm going to say start like this. We understand also that car depends on engine. So in this case here, because we know before we instantiate a car, we will need to have that engine. So of course, what we could do is inside of our car class, we'd create a val, right, a property that is going to be our engine. So in this case here, I am injecting a dependency into our car, in this case the engine. So let's say instantiate our engine as such. Inside of our start car, I can even append. I can say something like this: engine dot start, because I have an engine object in our car. We injected that dependency, so we can invoke the actual engine. I'm going to say, for instance, engine x, like that. All right, so we can go up here and say, for instance, val car is equal to car, right, instantiate it, and I can just go ahead and car start car like this. I'll actually put a body so that we don't end up with issues in our functions here. All right, so now in main here, I can go ahead and say val car and instantiate a car object, and I can say car dot start like this, or start car, that is start car. So I'm invoking this function here, which is, you remember, it gets the engine injected, right, object, and starts with that engine. So if I go ahead and run, I say print ln like this, making sure everything is good. If I run, you can see that we're going to have engine x started car. Of course, it's giving us Kotlin.unit here because we know that we, inside of a print ln, and engine.start also passes in a print ln. So that's not a problem. That's okay. But what's important here is, see, the engine x started because the engine here, you notice that we have injected this dependency here, okay, as an object. You can see engine x started. It's called because it's part of our car class, right? And of course, we invoke the starting the car. You can see that this is wonderful. It works great. We're able to add that dependency. So a car now, every time we invoke the car, we know that we have an engine. And we can do all sorts of things. In this case, in the start, I'm passing in the engine.start. I could have also created another function here that takes this engine and does other things, because we have access to this engine object as a property of this car. Now, what are the problems here? The problem number one is that this engine is always attached to this car class, which means every time we invoke or we instantiate our car, we're going to have a piece of this engine. This is not good because it violates the single responsibility principle that says each class needs to have a single responsibility. Now, our car doesn't have a single responsibility at all because we have yet another object there. So it's not loose per se. It's connected forever with this engine object inside of this car. This makes it really hard to write code that is testable, to write code that is flexible even, right? Because it's because of this coupling, this attachment that we have with our engine. Now, the better way to do this is by doing dependency injection, but by forcing this injection through the constructor. Well, this means instead of doing this, I'm going to say not good. instead of doing this way, what we're going to do instead, we're going to inject this dependency via the constructor. So you would say something like this: val engine, it's going to be engine type like this. So now things are a little bit different, because that means the car expects to receive an engine type, because we are directly injecting, right, this engine type into our constructor. Look what happens now. Inside of main here, I can create another val called engine, and it's going to be an engine object, right? We instantiating that. And then for our car here, look, we can pass that engine like this. So that's what we need to complete our dependency injection here. Now that we have this engine, because we're passing it along, not as attached like this inside of this class, right? All we do now is just create an engine. We can create as many engines as we want and just inject them in the constructor as such. Let's go ahead and see if run, right? Engine X started, starting car, same thing that we've seen before, the results. However, we've gained a lot of things, one of which is that we no longer are violating the single responsibility principle, because the car is not attached to the engine as we had before, right? So every time we create a car, previously we would have to also go ahead and create this engine, which is because it's attached inside as a property inside of this class. Now, that is no longer the case, because now what happens is that we're passing the engine object, the engine type, as a parameter in our construct. For instance, let's say I want to create another kind of engine. I can say class, let's call this turbo engine, okay? And turbo engine here, I'm going to have this fun start. This function here, we'll just say print ln, and say turbo. In our car here, I can just go ahead and say something like this. I can now inject another one, so val turbo, and it's going to be a turbo engine type as such, which means in our main here, we can instantiate a new engine and say turbo, and then I'm going to pass our turbo engine like this, okay? And look what I can do. For a car, I can say car dot, I can use the engine and invoke this start like this, or I can say car dot turbo dot start like this, because we were able to pass the engine, normal engine, and I can come here and change for our turbo X on normal engine. I'm going to say change this to start with normal engine, this start turbo engine, and then here in our car I'm going to just say, you can just delete all of this, that's fine. And now if I go ahead and run, you can see I have start with normal engine and start turbo engine. All of this is happening because we were able to inject that dependency via the constructor. And as you can see here, we can inject as many engines as we want. And we won't need to come and change anything inside of our class here, the main class, car class. Okay? Because the way things were before, every time we would have to come inside of our car and create another var at the bottom here as a property of this new engine, which would be, in this case, the turbo engine. Which means then we will end up with a lot of different classes that are being passed in as properties in this car, which is not a good thing, as we said before. So this is the power of dependency injection. Again, this is a simple example, but I hope it will start giving you some ideas on the reason why we want to use dependency injection, especially as we build our apps, because it gives us this flexibility to have our code that is decoupled from other parts, from other objects. And it's a very important concept in programming. This can get a little bit complicated and cumbersome, especially when we start adding more and more classes to your project and your project gets larger. So to manage all of these dependency injections can be hard. So there is a library called Hilt and Dagger that facilitates this whole process for us. Now, I have to say, these libraries are very complex in nature. There are a lot of articles that are being written just for them, to cover them. And the setting up of these projects into our project, it takes a little bit, right? Because there's a lot of different moving parts and different things that we have to do to get it all set up. But it is worth the time because you will get the full benefit of dependency injection, and you now know how advantageous that is. All right, so that's what we're going to be doing. That means we're going to be using Room, of course, to add that persistence layer to our app. And with that, to simplify everything, we're going to use this dependency injection, but not ourselves, but we're going to use this library called Hilt. So, but I want you to keep in mind that what I just showed you about dependency injection, that is the basis of these libraries, even though these libraries require a little bit more work to put things together. But the idea is the same. In the background, these libraries help us to abstract out this process of controlling these dependencies that we need with our objects. All right, let's go ahead and get started.